Hi students, welcome to the class. Today I am going to discuss straight lines topic, the entire topic in a maximum of 1 hour. Okay. So all IIT and JEE concepts, mains and advanced level concepts, all concepts including intermediate also, I will try to explain in the maximum of 1 hour. Okay. Try to listen the complete concept and watch the complete video. Okay, right. Now move to the topic straight lines. The first basic for this topic is nothing but slope. Okay. When a line intersects the x-axis, suppose this is x-axis and y-axis. Suppose a line intersects the x-axis with some angle theta, this is called inclination of the line. This is called inclination of the line. Always inclination is less than 0 to pi only. Okay, equal to 0 but not equal to pi, in between 0 to pi. Okay, now because the maximum of angle of straight line is nothing but 180, so inclination is just in between 0 to pi. If theta is inclination of the line, then tan theta is called slope of the line. Tan theta is called slope of the line. Generally slope can be represented the letter m. M is equal to tan theta. Okay. Now there are different forms to find slope. When inclination is given, this is the formula to find the slope of a line. Okay. Now suppose there are 2 points x1 y1 and x2 y2. There are 2 points on a line, then the slope can be defined as y2 minus y1 by x2 minus x1. Okay, when points are given, this is the formula to find the slope. When inclination is given, this is the point, this is the way to find the slope. And suppose the line ax plus by plus c is equal to 0, then what about the slope of the line? Minus a by b, which means minus of x coefficient by y coefficient. Okay. Now, what about the slope of the x-axis? X-axis slope is always 0, and y-axis, x-axis means the horizontal line. The slope of the horizontal line is always 0. And what about the slope of the vertical line? Vertical line slope is always not defined. Okay. Now, if suppose two lines are parallel, slope is unique for a line. You remember that point? Slope is unique for every line. There will be one slope. So we are having two lines, that means two slopes exist. Suppose there is one line slope m1 and another line slope m2. If the lines are parallel, then m1 is equal to m2. Suppose the lines are perpendicular, whose slopes are m1, m2, then the product of the slopes is equal to minus 1. When the lines are parallel, slopes equal. When the lines are perpendicular, product of the slopes is equal to minus 1. You think that all the lines may not be perpendicular, all the lines may not be parallel or perpendicular. So some of the line intersects with some angle theta. So angle between the lines, the formula is by using slopes is tan theta is equal to m1 minus m2 by 1 plus m1 m2. Okay. So these are the few things. When theta is acute means in between 0 to 90, then we have to write modulus, otherwise you leave it. So these are the few concepts depends on slope. Okay. Now going to the next concept, that is different forms of straight lines. When we have to use the straight line equations by the given condition. Okay. What about the given condition and what we have to use? There are different forms of straight line, different names of straight lines depend on the given condition. Suppose the first one is we have to know the word intercept. Intercept. What is meant by intercept? You see, suppose this line, a line intersects the x-axis at some point A, okay, which means the distance from origin to this line, the intersection, is equal to A. This is called x-intercept. Suppose there is a line which cuts the y-axis at some point 0, c, whose distance from origin is c. Now this distance is called y-intercept. So what is meant by x-intercept? If a line cuts the x-axis at some point, from that point to the origin, the distance is called x-intercept. If a line intersects the y-axis at some point, that point to the distance from that point to origin is called y-intercept. Okay. Now move to the equations. Different forms of straight lines. Different forms of straight lines. First you see, suppose y-intercept, this is C. Y-intercept is C and slope is M. we have to find the equation, this having the slope m. The slope of the line is m, and that line makes an intercept c with y-axis. If these two are given, then what about the equation of straight line? Y is equal to mx plus c. This is known as slope intercept form. Slope intercept form. Intercept means y-intercept only. That is the name of the equation. Slope intercept form. Y is equal to mx plus c. Now you see second one. Suppose x-intercept is a. That means this one is equal to a, and the slope of this line is equal to m. The slope of the line is equal to m, and x-intercept is a. Here slope and y-intercept are given. Then what about the equation of the straight line? Y is equal to m of x minus a. So this is the equation of straight line. When we have to use this one, when slope and x-intercept is given. This is when slope and y-intercept are given. Suppose you see here a is equal to 0 or here c is equal to 0. Then what happens? That means x-intercept becomes 0, here y-intercept becomes 0. Then the straight line passing through origin. The straight line passing through origin. So what about the equation? Y is equal to mx. So y is equal to mx is a straight line which is always passing through origin. So we have to remember these three. Okay. Now move to, this is when we have to use this one, y-intercept slope. This is x-intercept and slope. Suppose if both the intercepts are given, then what about the equation of the straight line? Suppose this is x-axis and this one is y-axis. There is a line whose x-intercept is a, that means the distance here is a, and here the y-intercept is b, which means the distance is b. Then what about the equation of the straight line? X by a plus y by b is equal to 1. This is one of the famous equations, straight lines, because we have to use that formula number of times as our name we write in intermediate books. Okay, so this is the very important one. When x-intercept is a, y-intercept b, then what about the equation of the straight line? X by a plus y by b is equal to 1. I want to say some important points regarding this intercept form. You see, suppose if intercepts are same, that means x-intercept is equal to y-intercept. If both intercepts are same, then you can write the same letter. Now x by a plus y by a is equal to 1, which means x plus y is equal to a. So this is the equation where the intercepts are equal. For suppose if the intercepts are equal in magnitude, opposite in sign. Okay, equal in magnitude, opposite in sign. That means x is equal to 2, x-intercept is 2, y-intercept may be minus 2. Okay, or x-intercept is negative, but y-intercept is positive. Whatever it may be, but the values are same. Okay, or sum of the intercepts is equal to 0. A plus b is equal to 0, or equal in magnitude, opposite in direction. That's why that mean that a is equal to minus b or b is equal to minus a. Now the equation will be x by a, y by minus a is equal to 1. Now the equation becomes x minus y is equal to a. Now there will be some questions like the ratio of the intercepts. The ratio of the intercepts a by b is equal to m by n. Ratio of the intercepts is given a by m. Now better you take any of the value. B is equal to, what about b? Na by m. Now the equation becomes x by m plus y by b means Na by m is equal to 1. Then you put a point that was given in the question, then you will get the value of a. So that there ends the matter for the equation of this triangle. Okay. Now the area of this triangle. Now the area of this triangle is half into, this is base into height, half a into b. What is a? X-intercept. B means y-intercept. So the formula is half into x-intercept into y-intercept is the area of triangle when a line, for this line with coordinate axis. So these are the few points on intercept form. This is called intercept form. X by a plus y by b is equal to 1 is called intercept form. Then go for another straight line, that is normal form of a straight line. Okay, when we have to use that normal form, you see, suppose there is a line like this. There is a line like this. Okay, and here is the perpendicular is drawn from origin. Perpendicular is drawn from origin, and this perpendicular, or we can call it as normal. Perpendicular means normal, we can call it as, if this normal makes an angle alpha with positive direction of x-axis. This is the normal which makes the positive x-axis is alpha, and the distance is equal to p. Okay, then this equation, the equation of this line is nothing but x cos alpha plus y sin alpha is equal to p. This is the normal form of a straight line. Okay, what about alpha? Alpha is the angle made by the perpendicular with positive x-axis, and p is the perpendicular distance from origin to the line. You have to remember that one. Suppose there is an equation like 2x plus 3y minus 4 is equal to 0 or plus 4 is equal to 0. We have to convert this equation into normal form. What to do? Now you take 2x plus 3y is equal to minus 4. Okay, this should be of the form x cos alpha plus y sin alpha is equal to p. Okay, now here p, what about p? P means perpendicular distance. So here is minus 4. So distance cannot be negative. So you have to multiply entire equation with minus. Then you will get minus 2x minus 3y is equal to 4. Next step, you have to divide the complete equation with root of minus 2 square plus root of minus 3 square. That is minus 2 by 4 plus 9, that is root 13 of x plus minus 3 by root 13 of y is equal to 4 by root 13. So when comparing cos alpha is equal to minus 2 by root 13, sin alpha is equal to minus 3 by root 13, and the perpendicular distance is nothing but 4 by root 13. So this is the way to convert one equation into normal form. Okay, now one more form, that is so we have to remember this here, alpha is not the angle made by the line with x-axis. You have to remember, that is very important point. Everyone do mistake at this concept. Alpha is the angle made by the normal but not the line. Okay, now move to the next concept, that is next one more form of a straight line, that is a symmetric form of a line. What is meant by symmetric form of a line? Suppose before going to prove the symmetric form, you have to know two equations. When one point and a slope is given, point and a slope is given, this is one of the heart of the straight lines topic. Whenever to find an equation of straight line, we require two things. One is point, other one is slope. If you know these 2 points, we can find the straight line equation very easily. So what about the form of straight line when a point and slope is given? Y minus y1 is equal to m of x minus x1. So this is the very important formula to find an equation of straight line when one point and slope is given. Okay. Now suppose 2 points are given. Then what about suppose there is a straight line which is passing through x1 y1 and x2 y2. Then what about the straight line? We have this formula. Then you can use one of the point and slope. So you take the first point y1 x1, or you take second point also, no problem. Whatever might be the point, you can take, the answer will be the same. Remember that one. So y minus y1 is equal to slope. What about the slope? When 2 points are given, y2 minus y1 by x2 minus x1 of x minus x1. So this is the equation of straight line when 2 points are given. So these are the two formulas when a point and slope is given, when 2 points are given. This can be called it as point slope form, point slope form, point slope form, and this is called 2 point form because 2 points are given. This is called 2 point form, and this one is point slope form. Okay, now going to the next symmetric form of straight line. Okay, what about the symmetric form of straight line? You see, y minus y1 is equal to m of x minus x1. Just we learned this one. And slope is, suppose theta is the inclination of the line. If this is given, then what about theta? Tan theta is called slope of the line. Now I am writing tan theta as sin theta by cos theta into x minus x1. So y minus y1 by sin theta is equal to x minus x1 by cos theta, which is known as symmetric form. There is no importance for symmetric form, just you leave it. There is no importance for symmetric form. Even in intermediate also, it's just leave that concept. But this concept is useful to another very important one, that is a parametric equation of straight line. In straight line, there will be two different concepts. One is normal form and another one is parametric equation of straight line. These two are very typical to students. Some of the students which they cannot understand properly. And suppose this is the symmetric form. Now I am taking this one as r, and we can, after solving this, we will get x is equal to, because r is the distance I am taking, we can take modulus r. So when leaving the modulus, we can write plus or minus. So now x comma y is equal to, we can write it as x1 plus or minus r cos theta and y1 plus or minus r sin theta. This is called parametric equation of the straight line. This is the last and final form of the straight line. Don't go away, because the straight lines topic is not completed. Just this is the last equation of straight line only. Okay, there are many concepts. Okay, watch complete video, because within 1 hour I am going to tell the complete topic straight lines, including IIT level also. Okay, just to listen. This is the point, is called parametric equation of the form. When we have to use this formula, that is very important. Suppose there is a line. This is one of the important one which we can use in secondary circles, parabola, ellipse, and hyperbola. Many concepts we can use this formula. Okay. Now suppose there is a line where x1, y1 is 1 point on the line. That is given in the question itself. 1 point is given on the straight line. Okay. And we have to find 2 more points on the same line. There will be 1 point here A, and here is 1 more point B on the same straight line, which are at a distance of constant distance from the given point. Okay. There are 2 more points which are at same distance or from the given point, and this line makes inclination theta. Okay. There are the 3 points. X1, y1 is point on the line, and r will be the distance from the given point to the required point, and theta will be the inclination of the line, inclination of the given line. If these 3 are given, we can find the 2 points by using this formula. This is one of the important one. When we have to use one point is given, and distance is given, and inclination is given. If these 3 are given, then we can find these 2 points by using that formula. So there ends the matter for finding the equation of straight line. Then go for the different concepts, remaining concepts. Distances. The next important concepts are distances, and the one more equation, that is the general form. These are all the different forms of straight line, and after finding these all type of equation, you will get one equation as a linear equation of the form ax plus by plus c is equal to 0. I told you 7 to 8 types of equations to find an equation of straight line. After the completion of finding equation, you will get one answer. That answer should be of the form ax plus by plus c is equal to 0 only. This is called general form, standard form of straight line. Okay, but both the a and b should not be equal to 0 at a time. That is very important. Both should not be equal to at a time. Suppose if a is equal to 0, b is equal to 0 happens, then c is equal to 0. There is no straight line equation. Okay. Now, if a is equal to 0, okay, no problem. If b is equal to 0, no problem. If c is equal to 0, no problem. I will explain what happens if a, b, c all are not at a time equal to 0. Suppose if constant is equal to 0, there is no constant. Then what happens? In any equation of straight line, if there is no constant, which means that line is always passing through origin. You remember that point? Whenever in the equation of straight line there is no constant, that line is always passing through origin only. So if c is equal to 0, line passing through origin. Remember that point. Next, what about if a is equal to 0? Okay, before going to a is equal to 0 or b is equal to 0, we have to know few equations. That is the general equations. I think you know very well, but I will remember that concepts one more time. This is x-axis. Everybody knows this concept. This is x-axis. X-axis equation is equal to y is equal to 0. Why? Because on the equation of x-axis, at all point, you take any point on the x-axis, the y coordinate becomes 0. So that's the name of the x-axis, that is y is equal to 0. Then what about the equation of y-axis? X is equal to 0. Okay. Now x-axis equation is y is equal to 0, y-axis equation is equal to x is equal to 0. Okay. Now suppose there is a line which is parallel to x-axis. In this line also, the y coordinate will be the same. Y coordinate will be the same. So at a distance, suppose it is at a distance of k units. Then what about its equation? Y is equal to k. Suppose the line will be here at the same distance. Its equation is equal to y is equal to minus k. So we have to remember that point also. What is that one? A line which is parallel to x-axis. That equation is equal to of the form y is equal to k. Suppose there is a line which is parallel to y-axis. Its distance is equal to L. So its equation is equal to x is equal to L. Why you are calling x is equal to L? On this line, the x coordinate always equal to L only. So any line which is parallel to y-axis is always of the form x is equal to L. So you have to remember these 2 points. A line parallel to horizontal line equation is y is equal to k. Vertical equation is x is equal to k. Okay. Now you see, suppose if a is equal to 0, then what happens here? If a is equal to 0 means by plus c is equal to 0. Y is equal to minus c by b. So y is equal to constant. That means the line is parallel to x-axis. Okay, if only b is equal to 0, then x is equal to minus c by a, which means x is equal to constant model. X is equal to constant means a line which is parallel to vertical line. So these are the few points regarding this equation. Okay, now I am going to convert this equation into intercept form. Then what happens? So ax plus by is equal to minus c, that is x by minus c by a, y by minus c by b is equal to 1. Okay. Now you see, this is x-intercept and this one is y-intercept. There is no necessity to write the equation in intercept form. Just you can put x is equal to 0, you will get the y-intercept. And put y is equal to 0, you will get the x-intercept. Okay. Now this is of the form intercept form. Okay. Now this is x-intercept and this one is y-intercept. And you see, intercept form line will be always like this. What about the area of the triangle? I already told you, half into x-intercept into y-intercept. So that is half into x-intercept into y-intercept. That is half into c square by ab. C square is always positive. There is no necessity to put a modulus for c square. It's shameless. Okay. Now we put modulus here. That is equal to area of triangle is equal to c square by 2 mod ab. So this is one line. What about the two remaining lines? For every triangle, there will be 3 sides. I think you to know very well. One line is given ax plus by plus c is equal to 0. What about the remaining 2 lines? One is x-axis, the other one is the y-axis. So if a line makes a triangle with the coordinate axis, then that area of the triangle is c square by 2 mod ab. Constant square by 2 into a means x coefficient, b is y coefficient. This is one of the formula. You have to remember this one. Many times in MCET type of examination, the type of question will be given. Okay, this is the area of the triangle with the coordinate axis. Next, move to the perpendicular distances. Okay, there are three formulae depends on perpendicular distance. One is the line is same, ax plus by plus c is equal to 0. Line will be the same. The perpendicular distance from origin. Perpendicular distance from origin. What about the formula? Mod c by root of a square plus b square. If you want to know this proof better, you see my previous videos. There will be proof and everything. Is a detailed explanation will be there. Just this is at a glance of 1 hour. We are going to complete the straight lines topics. So that's why I am not telling the proof itself. Just to listen the formula. From the origin, the perpendicular distance to this line is nothing but modulus of constant by root of x coefficient square plus y coefficient square. Now, suppose there is a point alpha comma beta. What about the perpendicular distance of this line from alpha comma beta? Just you substitute that point. Whenever a perpendicular distance to going to find, just you substitute that point by modulus of by root of x coefficient square plus y coefficient square. So that is when you substitute the point here, a alpha plus b beta plus c by root of a square plus b square. Okay, is it clear? Next, one more thing. These are the two perpendicular distances. One is from origin, other one is from a point. Now there will be 2 lines. Ax plus by plus c1 is equal to 0. Ax plus by plus c2 is equal to 0. These are the 2 parallel lines. How we identify those 2 lines are parallel? Because of slopes. If slopes are equal, lines are parallel. If not, directly we can by observing the equations, the x coefficient, y coefficients is equal, then that lines are parallel only. Okay. Now you see, suppose such type of 2 lines are given, then what about the distance between these 2 parallel lines? What about the formula? Modulus of c1 minus c2 by root of a square plus b square. That is, here is one important concept is the x coefficient, y coefficient should be equal here in the both the equations. If not, you have to compare the equation. Suppose 2x plus y minus 1 is equal to 0. 4x plus 2y plus 5 is equal to 0. Of course, these 2 are parallel. But don't try to use this formula directly. Because here is 2x plus y, here is 4x plus 2y. Then what to do? So, you multiply the first equation with 2. You will get 4x plus 2y. 4x plus 2y minus 2 is equal to 0. Now, you observe these 2. Here are the same. Then you can apply the formula c1 minus c2 by root of a square plus b square. Then you will get the answer for this question in correct way. Okay. Now this is the formula to find the distance between the parallel lines. And I will give one more important concept depends on this parallel. That is a line which is lying midway between the lines. one objective question like find the equation of the line which is lying midway between them. There are two parallel lines are given. There will be one line which is lying midway, exactly midway, which means this distance is equal to this distance. What about the equation of this line? Okay, the shortcut is ax plus by, because here is ax plus by, here is ax plus b. This line is also ax plus by only, because all the three are parallel. And what about the constant c1 plus c2? c1 plus c2 by 2. That is the shortcut to find the lying midway between the lines. Okay, now move to the next concept. Okay, and one more concept I'm going to tell that for objective purpose, that is how many lines are possible. How many lines are possible depending on perpendicular distance. Suppose this is a point and there is a line ax plus b. Whatever might be the line that was given, there is no necessity to equation of the line. Suppose there is a line and a point. This perpendicular distance will be the shortest distance. These are all distances. These are all distances from the points. Then what about the least distance? Perpendicular distance is the least distance. Perpendicular distance is the least distance. And the question will be like, there is a point, one point will be given and another point on the line will be given. Then how many lines are possible? If the distance is, suppose PQ distance is always D. D means perpendicular distance. Perpendicular distance is equal to this PQ, which means Q will be here only. Now, such lines are possible, only one line will be the possible straight line. And suppose if PQ is greater than D, PQ is greater than D. PQ is greater than means there will be two lines will be possible. Okay. If PQ is less than D, PQ means this distance is less than perpendicular distance. Is it possible? No. So such type of lines will be 0. Okay. So this is one of the condition, you have to remember that one. Okay. Next one, point of intersection of lines and concurrent lines. Next concept is point of intersection of lines and concurrent lines. You see, suppose two lines are intersected. Two lines are intersected. This is called point of intersection of straight lines. Okay, it is very easy. I think you know the formula, you know the procedure, how to find the point of intersection of two given lines. Okay, now suppose there are 3 or 4 lines, 5 lines, 6 lines are passing through the same point. That means all the lines are intersected some same point. That lines are called concurrent lines. That lines are called concurrent lines. So these are called a family of lines. A family of lines which are intersected one point. Okay, such type of lines, family of lines can be represented of the formula L1 plus lambda L2 is equal to 0, or lambda 1 L1 plus lambda L2 is equal to 0, where L1 L2 belongs to the any of the two lines of this family. Okay, you can take any of the two lines from this family. L1 plus lambda L2 is equal to 0, where lambda not equal to 0. Okay. So, or this form, whenever you see such type of equation is given in the question, which means that lines are intersect lines or concurrent lines. Okay. So this is the way to represent a concurrent lines. A family of concurrent lines always represent like this. Suppose the questions will be like, suppose ABC are in AP. Then what about the line AX plus BY plus C is equal to 0 always passes through. The family of lines means passes through. If ABC or AP means 2B is equal to A plus C. So A minus 2B plus C is equal to 0. So we can write A into 1 plus B into minus 2 plus C is equal to 0. While comparing these two equations, we get X comma Y is equal to 1 comma minus 2. So these are the few questions related to this one, concurrent lines. Okay. Now there will be, suppose the question will be like, there will be two family of lines. One equation like this and another one is this equation. This represents one family of equation, this represents the another family of equation. Then find the equation which are passing through two family of lines. The questions will be like this. This is a straight line family and this is a concurrent lines family. Two family of lines, concurrent lines. We have to find an equation of line which passes through both the families. That means the line will be like this. Okay, how to find such equations? First you solve these two equations, you will get 1 point. Then you solve these two lines, you will get one more point. Then using that point and this one, by using these 2 points of intersections, you can find the straight line. That straight line will be the passing through the belongs to the both the families. Okay, now go to the concept. This is about concurrent lines. Now foot of image and foot of perpendicular I will explain. And before going to that, optimization, maximization or minimization, that concept is also there. And I can explain after the foot of perpendicular image. Just you see the foot of perpendicular. The foot of perpendicular and the image are two important concepts which will be useful in the second year also. Maximum of the straight lines concepts will be used in the second year, circles, parabola, ellipse, hyperbola concepts also. So you have to remember these formulae whenever you have the whenever you need these formulae. Just you watch my video. Okay. Now foot of perpendicular. Suppose here is a point x1, y1 and here is a foot of perpendicular. This is called foot of perpendicular and this line is ax plus by plus c is equal to 0. So there is a perpendicular drawn from x1, y1 on this line where foot of perpendicular is h comma k. Then what will be the condition? H minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. H minus x1 by x coefficient, k minus y1 by coefficient is equal to minus of, just you substitute the point here by x square coefficient plus y square coefficient, you will get the foot of perpendicular. In the same way, foot of perpendicular. Okay, now image. Now here is x1, y1 and here is a ax plus by plus c is equal to 0 and the image will be h comma k is here. And you see here they don't ask like directly image, find the image. In intermediate level they can ask directly find the image of the point with respect to your line. They will be such type of questions. But in object orientations you have to remember this line is perpendicular bisector because this point is image, which means this distance is equal to this one. Okay, the image of this point falls like this. Okay, so this one, the distance from here to here is equal to here. Okay, now and what about this point? This point is just nothing but the midpoint of these two. Okay, midpoint of these two is equal to these two. This point lies on this line. Okay, so this is perpendicular bisector. Whenever perpendicular bisector concept is there, just you have to remember image concept. That is one of the important one. So what about the relation like this same, h minus x1 by a is equal to k minus y1 by b is equal to minus 2 of ax1 plus by1 plus c by x coefficient square plus y coefficient square for the concept of image. And the problems will be like suppose one vertex will be given, one vertex of the triangle will be given like this, one vertex of a triangle will be given. So this is one vertex is given and there are two more vertices for a straight line. And perpendicular bisector of AB is given and perpendicular bisector of BC is given. Find the vertex C. First type of questions will be there. You see, perpendicular bisector means this distance is equal to this one. So B is nothing but the image of A with respect to this line. So we have the point B. When we know the point B, C is nothing but the image of B because it is also perpendicular bisector. Okay. So you see such type of questions are there in objective purpose. And remember one more concept for the image, that is I will explain one more time. This is image of a point with respect to line. Suppose there is a point like this. Here is a point x1, y1. What about the image of this point with respect to x-axis? Image of this point with respect to x-axis. That means this line acts as a mirror. So its distance is equal to here and but lies in the fourth quadrant. So you can write x1 comma minus y1. Okay. What about the image of this point with respect to y-axis? Here the point will be here minus x1 comma y1. What about the image of this point with respect to origin? So origin is the midpoint. Now the point will be like this, x1 minus x1 minus x1 y1. So this will be the rectangle. This is always be a rectangle. Of course, if the point having the same coordinates x1 y1 is equal to same, then the quadrilate is nothing but square. So this is the image of a point with respect to the line and with respect to origin. Okay. Now there will be one more concept which is not useful for intermediate level and IIT level, that is image of a line with respect to another line. Before going to that concept, I will discuss angular bisectors. Angular bisector, this is also not there in intermediate level, it is exclusive for IIT level only. Okay, which suppose two lines are intersected. There is one more formula I just forgot, that is I already told you at the beginning of the class, if two lines are intersected with some angle, then what about the formula? Tan theta formula. When we know the slopes, we can write the formula m1 minus m2 by 1 plus m1 m2. This is the formula to find the angle between two lines. Suppose the lines are of the form a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Suppose the lines will be like this, then you can find the angle by using the formula cos theta also. Cos theta is equal to product of x coefficients plus product of y coefficient square by root of x coefficient square plus y coefficient square into root of x coefficient square plus y coefficient square. You can find cos theta. Or there is no necessity to find by using cos theta, tan theta, sin theta. Just you remember one formula. Okay. From that formula you find the angle between the lines in tan. Then use the diagram. Suppose you got a tan theta is equal to 3 by 4. That means this is 3, 4 and this one is equal to 5. What about cos theta here? 4 by 5 and sin theta is equal to 3 by 5. It is very easy. There is no necessity to remember all the formulas. But you remember this one also. Okay. Whichever you like, you remember that formula. Okay. Next, what is meant by angular bisectors? Angular bisectors between the lines. Okay. Angular bisectors between the lines. Suppose these are the two straight lines. Two straight lines. There are the two straight lines. Okay. Intersect at some point. Okay. The angle between them is theta or something 60 degrees, 40 degrees, 40. This is called internal angle and this one is called external angle. And there is a line which divides the angle between into two equal parts. Suppose the 1, 2, these are the two given lines and the angle between the lines is 60 degrees. There is a line which cuts the angle into equal parts, that is 30 degrees and 30 degrees. That line is called angular bisector. This cuts the internal angle and there will be one more line which cuts the external angle. Okay. So there will be two angular bisectors between the two lines. Here are two more important points. One is all the four lines are concurrent at one point. Two given lines, two angular bisector intersect at one point. And one more important point is these two angular bisectors are always perpendicular. Whatever might be the lines are given, whatever might be the lines will be given. The angular bisectors between the any two given lines are always perpendicular and passing through the same point of intersection. You remember that point. Okay. And one more point is from any point on the straight angular bisector, the perpendicular distances to the given lines are equal. Okay. From any point on the angular bisectors, the perpendicular distances are always equal. Okay. Now, what about this one? Ax plus by plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. These are the two straight lines that was given. We have to find the angular bisectors. Now, the angular bisectors between the given lines are, just you write a1x plus b1y plus c1 by root of a1 square plus b1 square is equal to plus or minus of a2x plus b2y plus c2 by root of a2 square plus b2 square. Just you write the first equation by root of x coefficient square plus y coefficient square is equal to plus or minus second equation by root of a2 square plus b2 square. Just to cross multiply and write one time plus and another time minus, you will get two equations. Okay. In these two equations, one is the acute angular bisector, other one is the obtuse angular bisector. How to identify whether it is acute angular bisector or obtuse angular bisector? You see, this is first equation, this is third equation, and while you taking the plus equation, you get the 3, and while you take the minus, then you will get 4, equation number 4. I am assuming like that. Given equations are 1 and 2, two angular bisector, one is third equation and another one is fourth equation. Just you take any one from given lines, any one from angular bisector. Suppose I am taking 1 and 3. This is given line, this is one of the angular bisector. Suppose when you find the angle between these two, which is less than 45 degrees, less than 45, not 90, because it is an angular bisector which divides the angle into two equal parts. Now, if the angle between one of the given line and one of the angular bisector is less than 45 degrees, then that line, if the angle is less than 45, then only we can call that angular bisector which we taken, that is called acute angular bisector. And of course, the other one is obtuse angular bisector. Okay, so that will be the concept, acute angular bisector and obtuse angular bisector. Okay, now optimization. This is also not exclusive for IIT only, but not there in intermediate MSET level also. Okay, now optimization means maximization and minimization of a point with respect to given line. There will be two lines, and before going to that concept, we have to remember one more concept that is also very important, that is the ratio of a line with respect to another line. Suppose there is a line having 2 points, joining 2 points ax1 y1 and bx2 y2. There is a line which is passing through these 2 points, and there will be one more line, ax plus by plus c is equal to 0. I am calling this equation as L is equal to 0, line 0. Okay, this equation, this line cuts the equation into some ratio. So that ratio formula is minus L11 by L22, minus of L11. If you want to prove, you see the previous videos, there will be proof and everything will be there. Just at a glance I am saying this. So the formula is minus of L11. What is meant by L11? This is the straight line equation. We are substituting x1, y1. So we can call it as L11. Okay. In the equation of the straight line L, we are going to substitute x2, y2. So it is L22. Okay. L22. So the formula is minus L11 by L22. This is the way to find the ratio. But you don't see the ratio as negative. Okay. If the ratio comes as a negative, you have to say m by n externally. Okay. If the ratio is positive, you can say that m is to n, or you can call it as m is to n internally. But you don't say the answer as negative. That is not that is one of the important point. Suppose here is the two important points is, this is the way to find the ratio. Suppose if this comes as positive, minus L11 by L22 positive, which means the line cuts like this internally, then the 2 points will be opposite sides to the given line. So if minus L11 by L22 greater than 0, then the points A and B lie on the opposite sides to the given line. Okay, in the same way, minus L11 by L22 is less than 0. What about negative? Negative means it divides externally, so the line will be like this. Now the 2 points are on the either this side or that side. So A and B 2 points on the same side. When a line cuts another line where the ratio minus L11 by L22 is less than, the fraction part is less than 0, then the 2 points lie on the same side. So you remember that point also. And next, maximization and minimization. In the maximization, minimization means it is called optimization. Suppose there is a line like this, and here will be 2 points A, and here is one more point B, and there will be any point P such that PA plus PB is PA minus PB is maximum. PA minus PB is maximum. The maximum of PA minus PB is equal to maximum. Okay. Now, where will be the maximum? Suppose you take you expand this line and hit this line. Okay. You can find the image of B here. You can find the image of A here. This is A dash, and we can call it B dash. Okay. So now PA is equal to PA dash. What we have to find? PA minus PB. So this is PA and PB. Now it will be the maximum where you can take PA as PA dash. Now PA minus PB means PA dash minus PB. You can write like this. Okay. Now one more concept is maximization. So what I write? I wrote the wrong one. I think so. You see, this is PA plus PB. This is P, and here is B. PA plus PB is equal to minimum. PA plus PB is equal to minimum, and PA minus PB is equal to maximum. So like this, these are the 2 points A and B. Whenever they said minimum, So PA plus PB is minimum. So you represent this. Just you find the equation of this line and given line. This will be the point of intersection. That will be the point. If it lies on this line, that distance is the minimum distance. And here is the maximum, PA minus PB. Okay. Now, what about the concepts is there? Next, reflection of a light and reflection of a light. In this concept, reflection of a light means, suppose there is a reflection surface and there is a light ray coming to passing through some point, or a light ray, a beam of light coming to this like this, and it reflects on the surface. This is called reflection surface. This is called reflection surface, and this is called incident ray. This is incident ray. It falls on the reflection surface and then goes like this. This is called reflected ray. Reflected ray. Here the angle is theta and here the angle will be the theta. Okay, and there will be a line which is perpendicular to this reflected surface is called normal. Is called normal, which is perpendicular to the reflection surface, and here the two angles will be equal. Okay, so here the important points are this is called incident ray, and here this angle is called angle of incidence, and this is called angle of reflection. Okay, these two are equal. Angle I is equal to angle R, which means the angle between incident ray and normal is equal to the angle between the normal and the reflected ray. You have to remember that point. And one more important point here is, suppose if we extended the reflection ray and the incident ray, the image of any point on the reflected ray, the image of any point on the reflected ray with respect to this surface falls on the extension of incident ray, and the image of any point on the incident ray with respect to this reflected surface falls on the extension of reflected ray. These are the two important points we have to remember in this. Now I am going to the last concept, that is centers of circles, circum center, ortho center. I will explain. If there is any concept I will miss, I will see one more concepts. Okay. Now you see, and one more concept is there, Seva's theorem and Siva's theorem and Siva's theorem and Menula's theorem. These are the two concepts we have. That is Menula's theorem is first one, Menula's theorem, Menula's theorem, Menula's theorem, and another one is Siva's theorem. So these are the for exclusive objective purpose only. What is meant by Menula's theorem? Suppose there is a triangle like this. There is a triangle like this, ABC. For this triangle, there will be a line L which divides the three sides of the triangle like this at D, E, F. There is a line which divides the three sides of the triangle at D, E, F. Then the ratio BD by DC into BD by DC into CE by EA, CE by EA into AF by FB is equal to, product is equal to -1. You see, this is a line which cuts three sides, this side at F and this side at E and this side at D. Then the ratio BD by DC, CE by EA, AF by FB is equal to -1. And what about Siva's theorem? If there is a triangle ABC and here is a point P such that the line joining A to P meets the opposite side at D, the line joining B P meet the opposite side A and it is F, then the ratio BD by DC into CE by EA into AF by AFB is equal to 1 only. Okay, this is -1, this is 1. What is the difference between these two? There is a point inside the triangle. There is a point inside the triangle and the line joining vertex to the P meets the sides at D, and here is one line cuts the all the three sides. Okay. Now centers of triangle. Now the last one is centers of triangle. Now that is first centroid. What is the meaning of centroid? And there will be, I will draw three triangles and look at these triangles. This is one triangle and this is one more triangle and this is one more triangle. Okay. Now suppose this is ABC triangle and this one is the midpoint. This is called median. This is called median and this is called altitude and this is called perpendicular bisector. Okay, what is the difference between these three? Among three, this is one vertex and this is midpoint of opposite side. The line joining midpoint to the opposite vertex is called median, and it is just perpendicular. There is no significance which is passing through the vertex, so we can call it as altitude. And this is both these two happen, passing through midpoint and perpendicular to this side. This is called perpendicular bisectors. So here there will be three medians, and the median's concurrent point we can call it as centroid JEE. And how to find the centroid? If we are having three vertices x1, y1, x2, y2, x3, y3, then what about the centroid? x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. And one of the important point here in the centroid that is given in the 2020's September examination, that is, suppose here is centroid, the area of triangles are same. The area of triangle ABG, BGA, CBG, these triangle areas are same, and each triangle area is equal to 1/3 of the total triangle area. Okay, now this is altitude, and altitude concurrent point we can call it as orthocenter. Altitude means perpendicular, orthogonal means perpendicular, so remember like that only. So this is another altitude and this one is another altitude. Okay, altitude's concurrent points we can call it as orthocenter. Okay, how to find the equation of orthocenter? How to find the orthocenter for a triangle? Suppose three vertices are given, we have to put the triangle, that is very important. And you see this is AD, BE, CF. Okay, now we have to find the altitude. What about the altitude equation? How to find? We know this point. Then what about the slope of this line? So we know the slope of this line, and this will be the perpendicular. So we will get the equation of A. In the same way, we find the equation of B. We have the point B and we know the slope of AC, which means we know the slope of BE also. So we have two altitudes. By solving these two altitudes, you will get the equation, the two altitude equations. By solving these two, you will get the orthocenter. We can call it as H, sometimes we can call it as O. Okay, now this is a perpendicular bisector. Perpendicular bisector's concurrent point is known as Circum Center. Okay, there will be some this is called circum circle. There is a circle, circum circle. Okay, circum circle. What is the significance of circum circle? So a circle which passes through the three vertices of triangle is called circum circle, and the center is called circum center. Which here is SA is equal to SB is equal to SC. That SA, SB, SC is nothing but radius. That is called circumradius. Capital R. Capital R is called circumradius, and the circumradius formula is ABC by 4 delta. Okay, ABC by 4 delta. What is ABC? Lengths of the sides, and delta will be the area of triangle. And one more thing is angular bisector. Angular bisector. Incenter, that is incenter. Suppose the point of concurrence of angular bisector. This is the angular bisector, and this one is the another angular bisector, and this one is the another angular bisector. This is called incenter. That means there is a circle which touches all the three sides internally. That is called incircle. That circle is known as incircle, and the radius is called inradius. Inradius is smaller, where the formula is delta by S. What is delta? Area of triangle, and S is semi-perimeter. So for every right angle triangle, where the right angle vertex, this is the right angle vertex. This vertex is called orthocenter. Okay, and the midpoint of hypotenuse is known as circumcenter. There is no significance for right angle or any other triangle for incenter and centroid. Okay, for equilateral triangle, incenter, circumcenter, orthocenter, all those are coincide. Okay, and there will be X circles. This is called X circle, one X circle, another X circle, and another X circle. These are the three X circles whose centers are, I am assuming, I1, I2, I3, and this is incircle whose incenter is I am taking as I. Now suppose this is the triangle I1, I2, I3 will be the triangle formed with the X centers as vertices, and for this triangle the orthocenter is nothing but I. That is one of the point. And one more point is, suppose 3 points are given ABC. For a triangle 3 vertices are given A, B, C, and origin is the orthocenter. Now this is the orthocenter for this complete triangle. Now what about the orthocenter of this triangle HBC is A. What about the orthocenter of ABHC? The orthocenter of AHC is equal to B. That is one of the point. And one more concept, that is number of circles. This is the last concept, I think so. If I didn't forget anything. Number of circles. Suppose 3 lines will be given. 3 lines are given. Suppose the 3 lines are parallel. 3 lines may be parallel, maybe 2 lines parallel, or the 3 lines are not parallel, non-parallel. These are the 3 possibilities. Perpendiculars, there is no importance for perpendiculars. So, suppose 3 lines are parallel. How many circles are possible which touches all the 3 lines? Touches, don't intersect. This is not intersection. Just touches this circle, lines. There is no circle possible which touches all the 3 lines. So 0 circles are possible if the given 3 lines are parallel. Suppose 2 lines are parallel, which means one line doesn't parallel to the remaining 2. So it intersects the 2 lines. There will be 2 circles are possible which touches all the 3 lines. If the 3 lines are non-parallel, then they form a triangle. Non-parallel, non-concurrent also. Then number of circles which touches all the 3 sides is equal to 4. 3 x circles, 1 in circles. Next, suppose the 3 lines are concurrent lines. Then will be there is no circle. Of course, if you consider this point as point circle, there will be 1 point circle only. Otherwise, we can write 0 circles. Okay. There any concepts? Did I forget? I think none of the concept I forget. Okay. Okay. So these are the concepts. Suppose 3 points, how to prove collinear. Collinear concept. 2 or more points lie on a 3 or more points lie on a line. The points are said to be collinear. Collinear concept. Slopes will be same, or area of triangle is equal to 0. Okay. If 3 lines are given, how to prove the 3 lines are concurrent means we can use determinant form. So these are the total concepts of straight lines. Maximum, I think within 1 hour I completed all the concepts. You listen the video, complete video, and you share to your friends, and tell your friends also subscribe to my channel and listen carefully. Thank you.